Hey everybody, today we're going to take a look at the correct way to calculate annualized returns. So let's take a look at an example to start. Let's say that you have an 80% return over the course of 10 years. The incorrect way to do this, which is what you might see a lot of people do, is to do just some basic, what you would normally do for finding an average, which is to take the 80% and divide by 10 and then get an 8% return annual yield. This is not correct, but this is probably intuitively what a lot of you might want to do. The reason this is not correct is because percentages are a little bit different than other kinds of calculations. You can see really quickly that this is not correct because if you had a 8% return over the course of 10 years, we can do something like if you had $100 to start, you'll see that you would actually end up with $215.89. That's actually an 8% return over 10 years. Will actually get you about 115.89% return. So you can definitely see that's off by quite a bit. It's not 80%. So we can't just do division and make this work. So what is the correct way to do it? Well, to get it to do this correctly, we need to start with our exponential return formula. So that tells us that the final amount of any initial amount or the principal value is equal to the principal times 1 plus the return raised to the number of years that it has been compounding. So in this case, we want to do an 80% return. So we can just start with something like $100 and say that's going to grow to $180. It doesn't really matter which numbers you use, as long as the number on the left is 80% higher than the number on the right. We're always going to get the same calculation at the end here. I'll show you in just a second. We don't know what the rate is. That's what we're looking for, so we're going to leave that as R. We do know that it's been 10 years. So if you remember back to your algebra days, what you need to do to solve this is divide by 100 on both sides. That's going to give me a 1.8 on the left. And again, that's why it doesn't really matter which numbers you use, as long as you start with a number that's, as long as you get a number that's 80% higher than your initial, then this will always turn to a 1.8 on the left. All right, then over here on the right, we still have this 1 plus r hanging out to the 10th power. And now what I need to do to free that r is I need to actually take the 10th root. Okay, so take the 10th root of the right side. I need to also take the 10th root of the left side. That's going to undo the 10th power. So I have the 10th root of 1.8 is equal to 1 plus r. Finally, to solve for the r, you just need to subtract the 1 from both sides. So you get that the rate is going to be the 10th root of 1.8 minus 1. That's our annualized rate. Now, for typing this in the calculator, it's actually a bit easier. If you, instead of the 10th root, you can take it to the 1 over 10 power. All right, so let's see what that would be. So I'm going to take 1.8 raised to the 1 over 10 power. Be careful if you're putting this in a regular like handheld calculator. You might want to put this in parentheses. And then we're going to subtract 1. All right, so you can see here that our annualized rate is approximately 6.05%. All right, if we do a little bit of rounding. So that's actually the rate that you would get every year in order to get 80% return over 10 years. You can double check this by just popping it in to the calculator. So again, say you start with $100 and you want to get a 6.05 return over the course of 10 years. You can see you get up to about $180 right there. The reason this number is a little bit off is because this 6.05 is actually rounded. If I used the exact value, so like if I copied and pasted this in and then raised this to the 10th power, oops, should be a decimal here, then you see that's rounds right up to $180. That's an 80% return. So if you're curious like what formula you can use for like a spreadsheet, if you want to like run these numbers in a spreadsheet or something, the general formula you could use would be to say that your annualized rate is going to be 1 plus whatever your rate of return is. Okay, so your ROI, or your return on investment. So 1 plus your return. It's important that this is a decimal when you put it in. And then you want to have 1 over the number of years. That's going to be the power that you're going to raise it to. That's like taking the teeth root, and then we're going to always subtract 1 at the end. Okay, so we'll subtract 1 from that. All right, so and a quick example would be, say that you had a 160% ROI over 14 years, and you wanted to know on average. Let me get that in here at the edge of my screen. All right, so 160% ROI over the course of 14 years, and you want to know what's the average return, or the annualized return. That is the annualized return being what is the return you would have to get every year in order to get 160% return over 14 years. So we can just drop that into our formula. It's going to be 1 plus 1.6. That 1.6 or 1.60, that represents the 160% return. All right, we have to do it as a decimal. So remember, if you just move this over 2 places, that's where the decimal goes, going from a percentage to a decimal. So then we'll raise that to the 1 over 14th power and then subtract 1. And that should get it for us. So let's see what we got. So 1 plus 1.60 raised to the 1 over 14th power. And then we're going to subtract 1. So you would need approximately a 7.06% return every year in order to get the ROI that you're looking for. This is really helpful because if there's a certain rate of return that you need to get, you can figure out, is it feasible? For example, if you want to, double your money. And let's say you want to double your money over 5 years, is that going to be practical? Is there a way to do that easily? Well, you could just plug this in, say 1 plus 100%, so that's 1 plus 1, and we want to do this over 5 years. So what rate of return would I need to get every year so that after it compounds, it will double in 5 years? And I suspect this will be a pretty good return, pretty good size. 1 divided by, so that'll be 1 plus 1 to the 1/5 power, and then subtract 1. Yeah, so we need to get about a 14%, about a 15% return actually, which is pretty high. So this is good for kind of testing your plans for if you're trying to have a certain amount of money over a certain amount of time. You can see if those returns would be feasible or not.